All right, so we're going to start off with what the definition for statistics is. So there are two different ways we use the word statistics: lowercase s statistics and then uppercase s statistics. So uppercase s statistics is what we're doing in this class. We are making sense of the world around us using data. So I'm going to jump in to an example that we have here. I'm going to just chat about this example. Based on historical data, a student placed in Math 38, 3 levels below transfer, has only a 7% chance of passing transfer level math within 3 years. So I'm going to dive a little bit deeper into this. We're going to talk in class on Friday about ways that we know that statistics is used around us. And one of the biggest ways that statistics is used, or one of the ways that has the most impact on me and on you, is in education. So I'm going to give you an example. Recently, legislation was passed, maybe about a year ago, but it's now in effect starting this fall. And this legislation was called AB 705. This AB 705 was completely born from this particular piece of information. This idea that being placed into Math 38 gave you only a 7% chance of passing through transfer level math. So for those of you who've been at Mesa for a while, you might know what Math 38 is. For those of you that don't, let me explain really quickly what AB 705 did. AB 705 said, well, we know the old way of doing things, I'll just write this out, you don't need to write this down. The old way was you came to Mesa and you took a placement test. So my students who've been here for a while remember doing this, sat down on a computer, and you probably saw a ton of fractions. And for most students, fractions are just no bueno. I'm not sure I'd be great with fractions without a calculator even. I could handle it, but I would not be happy about it. And so students would either blow off the test, they would just not know the fractions, whatever it would be, and they get placed at Math 38, which was our pre-algebra class. And then you had to go through Math 46, which was Algebra 1, Math 96, which was Algebra 2, and finally, you would be allowed to take Math 119. You would be deemed ready for transfer level math. So all these 3 classes were what we call developmental math or basic skills. And people looked at the data. They said, okay, what's going on here with this data? We have a lot of students who aren't getting out of community college. What's the problem? And again, the data said they're not finishing math. In fact, a lot of them are getting stuck in this pipeline. There's a lot of reasons for that, and the data showed them this. One reason is, between every one of these classes, a student who passes Math 38 should move on to Math 46. But what was really happening was about 25% of the students who passed the class would just not enroll in the next class. They would drop out of school, something would happen. And that happened every single time. They would lose 25%. So that was a big problem. And that was of the students who actually passed the class. Now, a lot of students got stuck in these algebra classes because they're not contextualized. As somebody who's taught a lot of these courses, it's really hard when a student says, well, how am I going to use this in real life? You're like, you won't. You won't need to factor in real life. So for a lot of students, without being able to see how this mattered to them, they weren't doing so great. And then the biggest problem and the biggest argument for AB 705 was not only the fact that the overall pass rate out of all of this was 7%, but it was that the students who were getting placed here in Math 38 were disproportionately students of color. And so there's something going on here. Many states decided on a different way. So their new method was, instead of having all this crap, let's just put them in 119. But let's put them in 119 plus, well, let's say a little plus sign, a support class. So they can take stats. You really don't need a whole lot of algebra to be successful in statistics. Let's just give you a little class that'll support you in the algebra and maybe some of the college readiness skills that you get from suffering and making it through this entire thing. So we have that now. That's what we call our 119X. I do have openings on my Monday, Wednesday, Friday if you feel like you might need more support. But this is where we are now, and this was all born out of looking at this data. So in education, AB 705 is a very real, very relevant way that statistics has been used. So bringing us back up here, there are two types of statistics that we're going to be studying. We have descriptive statistics, which this 7% pass rate could be considered a descriptive statistic, and inferential statistics, which is where we try to draw conclusions or make predictions based on what the data is telling us. So this particular statement, the fact that we're saying the person has a 7% chance, that's like saying we have a prediction, right? That's why this becomes an inferential statistics statement. It could have been given as a descriptive stats statement as well, though. We could have said, in the past, 7% of students have finished transferable math within a year. I'm not trying to say that in the future that's going to continue to happen or that that's a probability. I'm just saying this is what's happened. That would be a descriptive stats. So it's sometimes hard and muddy to see the difference between the two because it really depends on the context. So descriptive stats are where we try to just organize our data. So 54% of students enrolled in MESA are planning to transfer. This is a descriptive statistic. Now, this might not be, because as I've been asking students, this is something I grabbed off of our website, a lot of students said they never told anybody whether they were planning to transfer or not. It wasn't part of their counseling, their intake, any of that. So how are they getting this number? If they're making this number off of a smaller subset or a sample, then we're talking about inferential statistics, if we don't know. So a better example of descriptive and inferential, the two different graphics here. The top 10 education plans, here they're just telling us the number of students in each of these ed plans. There's nothing that they're trying to predict here. They're just describing what the data tells them. Versus inferential statistics here, they're giving us historical success rate and projected success rate for these particular things. So this projection here is why we're dealing with an inferential statistic in this particular case. So we have these two types of stats. We're going to be doing descriptive stats in part 2. And we're going to be doing inferential stats in part 3. And then 6 and beyond. So most of this course is about inferential statistics, even though what you'll probably see most often in business is descriptive statistics, right? In whatever class, whatever you're doing, you see a lot more descriptive stats than you see inferential stats used in real life. All right, so our last topic here that I want to put on here, last definition, got descriptive, inferential, is just the lowercase version of statistics. This is the actual values. So this 7% would be a statistic. This 54% would be a statistic. This total number of students would be a statistic. This is just a value. Actually, this particular value is probably from every single student, so that would actually be a parameter. We'll get to that on the next page, but there's your different definitions on this page. Mostly the difference between big S statistics, little s statistics, descriptive and inferential. You're going to know what the difference is between these two. These are not things I test you on. So now that you've suffered through 8 minutes of video and realized why I told you to do 1.5 speed, I'm going to finally reveal this is not a test question. But I promise you on the next page and in the next video, we will see some test questions.